Hello, Year 5, and welcome to your maths lesson today. Now, I know that on Friday's Hot Task, there were some questions on the quiz that the computer said was wrong. The only reason for that is that there's only a narrow spectrum of answers that it recognizes. So sometimes if you put a correct answer in that's not one of those, then it won't register it. So I don't want you to worry about them. We still do go through and check them, even though it does automatically give you scores for it. So if you did get a couple right that you looked at and you thought, oh, blimey, that's not, I thought that was correct. Don't worry. Normally I'll go through it and I will just add a couple of comments on it as well if they're incorrect. If the answer is correct, but it was marked as incorrect. So I don't want you to worry about those. Our new topic is fractions, and we have got quite a few weeks of fractions ahead of us, so strap yourselves in a little bit. And there's a little starter activity here, just so that we can have a think of some of the different ways that fractions can and can't be represented. So there's 4 questions there that I want you to just have a think about. There's no template for them on Teams or anything like that. I want you to look at that top one and have a think about what fraction of that shape is shaded. The second one is more or less than a third shaded. The third one's a bit of a strange one, but what fraction of the circles are not red? And then the fourth one, what is half of 72? They all have something to do with fractions as their answers. So for the first question, we can see that the shape is split into 1, 2, 3, 4, 5 equal parts. And that 2 of them are shaded. So 2 out of 5 are shaded, which means 2/5 are shaded. Now with the second one, if you have a look at it, you can see it's split into 3 parts, but the parts aren't equal. So is more or less than a third shaded? Less, because the smallest segment is shaded in. If these 3 parts were equal, then we would say that it was exactly a third that was shaded. What fraction of the circles are not red? There are 6 circles and all 6 of them are not red. So 6 out of 6 of the circles are not red. And then what is half of 72? That means that we are splitting 72 between 2 groups, and that is 36. So that's just a quick introduction. Let's have a look at what we're doing today. So we're sort of reintroducing ourselves to fractions today. Some of you will be very au fait with them. Some of you will look at them in a bit of a confused way, but that's fine, because that's what this week especially is for, is exploring fractions, just reminding ourselves of some of the things about. So some of our key vocabulary. So a fraction represents a part of a whole. So if I had a whole chocolate bar, for example, and split it into parts, then I could say that I've split it into fractions. The numerator is the top number in a fraction, and that number represents the number of equal parts that we are using. The denominator is the bottom number in a fraction, and that represents the number of equal parts that there are, the number of equal parts that the whole has been split into. And that word equal will keep on coming up, because it's really, really important in fraction. The whole is all of something. And that we'll have a look at that again later on in the week when we talk about fractions that are larger than 1. So here are some examples of fractions. All of these are the same fraction, just shown in different ways. So we've got 1/4, 1 out of 4, 1/4. We've got 4 red dots, 4 dots, and 1 of them is red. So 1 out of the 4 dots is red, and we've got it written as your good old-fashioned classic fraction. What you will sometimes see as well is you'll sometimes see them written like this. That's a lot of the time because word processors and computers don't always like writing fractions. And so if you see something like that, then that is still a fraction, just in a slightly different format. So with a fraction, we've got 2 parts to it. We've got the numerator and the denominator. So the numerator is always the top number. It's the number of equal parts that we are using. So if we look back at our 4 dots, let me move these over here and then copy them across. We can see that the denominator is 4. So that's the number of equal parts that it's been split into, that these 4 balls have been split into. And then the numerator is the number of equal parts we are using. So we've counted 1 out of the 4 parts altogether. So that is what the numerator and the denominator mean. That's what they stand for. And the quicker that you start to understand that, the easier all of this work on fractions becomes. So let's have a look. We've got 3 pictures here. which of these represents 1/4, and why don't the other two represent 1/4? So why don't you just have a look at that quickly? If you've got someone that you can discuss it with them. If you haven't, then just have a think, and then I'll go through which one represents 1/4 and why. Okay, so let's have a look at 1/4 first of all. So I can see that my denominator, where's my highlighter, is 4. And that means that the whole has to be split into 4 parts. Now, straight away, I can look and see that this one is split into 1, 2, 3, 4, 5 parts. So that one can't be showing me 1/4 because that's actually 1 out of 5. So it's definitely not this one. Now, this one, although it is split into 4, the stars aren't equal. And we talked about how they have to be equal to show fractions. So we know it can't be this one. Now, if we have a look at the last one, we've got our whole is split into 1, 2, 3, 4 equal parts. And now we can have a look at the numerator. The numerator is 1, which means that we're looking for one thing that we're counting, and we've got 1 shaded. So there is 1 out of 4 shaded. 1/4 of this shape is shaded. So, and that's quite common misconceptions with these other two about why they might or might not represent 1/4. Now, what we've just been looking at is going to be very helpful for you today, but there are other ways that we can see fractions as well, because fractions can often represent something that is smaller than 1, and they are equivalent to something called decimals, which we will move on to look at some point this year. But that means that fractions can be placed on a number line. So here's my number line between 0 and 1, and I'm going to be focusing on quarters again. Now, again, I can look at my denominator and I can see that I need to split this number line into 4 equal parts if I'm splitting it into quarters. So here I've split it into 1, 2, 3, 4 equal parts. And if I show this, I can see that my number line has been split into 4 equal parts. Now, from 0 to here, that is going to be 1/4. We've hidden behind something. Each of these different segments is equivalent. Why won't it let me do this? Is equivalent to a quarter. And if I have a look at them, I can see that there are 1, 2, 3, 4 quarters to make up one whole. And if I have a look on here, I can see that we go 1/4, 2 quarters, 3 quarters, and then one whole. One whole can also be 4 quarters. And if I count these up, I can see, for example, here, it is split into 4 separate parts. But if I've got to this stage, I'm counting 1, 2, 3 of them, which is why it's 3 quarters. The numerator is not always 1. It depends on how many of the parts we are counting. So there's 2 jobs for you today. Oh, sorry, we'll go through these first. So are 2/3 of this shape shaded in? Have a look at it and have a think, first of all. Hopefully you've realized that this shape is not split into 3 equal parts. So we don't have 2/3 shaded in. Now in this shape, we do have 3 equal parts and 2 of them are shaded in. So that means that 2/3 would be written as, we've got 3 equal parts, so that's my denominator. 2 of them are shaded in, so we've got 2/3 here. This is another way of showing that. Just because the 2 shaded parts aren't touching each other doesn't mean that it's not 2/3. So we still have 2 out of the 3 shaded in. Now, what about this one? What fraction of this shape is shaded in? Now, I always start with the denominator personally. I ignore all of the shading and I have a look and see, right, how many equal parts is this shape split into? So 1, 2, 3, 4, 5, 6, 7. This shape's been split into 7 equal parts. Now I can look to see how many of them are shaded in. 1, 2. I can fill in my numerator. 2/7 of that shape is shaded. So how could we shade in a fraction of this shape? So I can see straight away that it's split into 8 different parts. So if I was looking to shade in 5/8 of them, then of the 1, 2, 3, 4, 5, 6, 7, 8 things that are there, 8 segments that are there, I would need to shade in 5 of them. So let's see if this will work. 1, 2, 3, 4, 5. Now I could shade in those 5. I could shade in 1, 2, 3, 4, 5 if I wanted. It doesn't matter what 5 I shade in, as long as I shade in 5 out of the 8 on there. So on Teams, there are some questions for you. I'm hoping that for fractions, they are all quite interactive, which means that there will be things like having to change the color on tables and shade things in like that. Fractions, I always find works better when it's quite interactive. Please give me feedback on whether the interactivity is working on Teams, because if it's not, then I'll have to see if I can come up with something slightly different. But I'm hopeful that you will be able to access some of those things. So here are your first set of questions. Obviously, if you're on Teams, then they are all online. So have a look and work through them. Here's your second set of questions. And your final set of questions. Do have a go at a few different ones, because it's good for you to see them as shapes, but also on a number line. And then an interesting one for you, create 3 different representations of 3/4. Can you have a go at that? I'm hoping that on PowerPoint on Teams, you're able to add shapes in and things like that, which will be helpful for that, or add number lines in, or possibly copy and paste from other bits. And here are your answers for the first set of questions, second set of questions, and the third set of questions. Hopefully you have managed to sort of get your head around some of those fractions. We will ease our way in this week. I know that you have looked at fractions before, but we will be looking at a few different parts of it this week before we go into the heavy stuff. So stay with me. If you're not sure about something, let me know, because it means that I can set up different groups for people who need to see it from a different angle, or come back and repeat this lesson tomorrow and just keep on looking at it, because it's really important, because I think we've got about 6 weeks on fractions. It's really important for you to try and understand this week's stuff so that you can apply it later on.